Have you ever just looked at all the data flying around us and wondered how anyone makes sense of it? Well, here's the secret. It's not really about being a math whiz. It's more like learning a new language, a way to speak to data so we can give you answers. And today, that's exactly what we're going to do. We're going to learn the basics of that language.
And really, this is the whole promise of data science, isn't it? The idea that you can take this huge, messy pile of information, things like customer reviews or climate data, and pull out the simple, clear story that's hiding inside. It's kind of a modern-day superpower. And just like any skill, it all starts with learning the fundamentals.
So, what's the actual job of a data scientist? Well, at its heart, it's all about answering really important questions. But here's the thing. The answers can't just be based on a gut feeling or a guess. No, they have to be built on a solid foundation of evidence. And that evidence, well, that's the data.
Look, we can't just chat with our computer in plain English and expect it to figure out complex statistical problems. It just doesn't work that way. We need a bridge, right? A special language that's built specifically for data, one that lets us give the computer super precise instructions. And that bridge is a programming language. The language we're going to be digging into is called R, and you can think of it as the common tongue, or the lingua franca, for the entire data science world. It's the language millions of analysts and researchers are using every single day to have these conversations with their data.
So what is R, exactly? Well, it's a high-level language. All that really means is that a single line of R code can do a whole lot of work, like creating an entire chart from scratch. But what's absolutely crucial is that it was built from the ground up for just one thing: statistical computing. It's not trying to build websites or games. It's a specialist, and that's its biggest strength.
Okay, so why do so many people choose to speak R? First off, it's totally free, which is amazing, right? It just opens the door for everybody. And it runs on pretty much any computer you can get your hands on. But the real power, the secret sauce, comes from its massive global community. These people are constantly building incredible tools, we call them libraries, that let you do cutting-edge analysis without having to write everything from scratch yourself.
All right, just like learning any new language, we've got to start with the basic grammar. In programming, that means we need to understand the fundamental building blocks. So let's think about them as the nouns and verbs of R.
So the nouns of our data language are called variables. And a variable is really just a name we give to a piece of information so the computer can remember it for us later. The best way to think about it is like a label box. The label is your variable name, and whatever you put inside that box is your data.
And here we go. This is actual R code. Now, that little arrow might look a bit weird at first, but all we're doing here is telling the computer, hey, take the number 92.5 and store it in a box labeled weight. That's it. We've just taught the computer a new noun and what it means. Okay, so if variables are our nouns, then functions have to be our verbs. They're the action words. Functions are what take our data, our nouns, and actually do something to them. They calculate, they transform, they summarize, they visualize. They're the real workhorses of this language. And here's one of those verbs in action. Just imagine we have a variable called ages that's holding a whole list of people's ages. When we write mean ages, we're giving a simple command. Take that list of ages and calculate the average. The function is mean, the noun it's acting on is ages, and the output it gives us back is the average age. See? Noun and verbs just working together. Simple, right?
So we've got our nouns and our verbs. But let's be real. Real-world data isn't just a few random words floating around. It's more like a whole book or a massive spreadsheet. We need a way to organize all this information so it actually makes sense.
In R, the main way we do this is with something called a data frame. And honestly, spreadsheet on steroids is the absolute best way to describe it. It holds all our data in these nice, neat rows and columns, but it's built to handle the kind of powerful analysis that would make a regular spreadsheet just completely fall over. And this is exactly what a data frame looks like. See how each row is a single observation? In this case, a cricket player. And then each column is a variable, a specific piece of info we have about that player, like their batting average. It's all organized, it's clean, and it's perfectly set up for us to analyze. Now, this is where things get really, really cool. A lot of the time, the answer to your most important question isn't just sitting in a single table. It's actually hiding in the connection between different tables. This is the whole idea behind working with what we call relational data.
So let's imagine we have this first table. It tells us student names and then gives us an ID number for the class they're in. We see Alice is in class 1, Bob's in class 2. But what is class 1? This table doesn't actually tell us. That piece of the puzzle is over here in a second table. This one connects that class ID to the actual name of the class. So now we can see that ID 1 is Maths and ID 2 is English. The information is totally split up.
So here's the crucial question. How do we bridge that gap? We've got two separate tables, and the real insight only comes when we put them together. How do we tell the computer, hey, look at Alice's enrolled in number, then go find that same number in the other table and pull out the actual class name for me?
The answer is a powerful command called a join. It's like magic. We just tell R to match up the rows where the enrolled in column from our first table is the same as the class ID column from the second. And bam, just like that, it builds us a brand new combined table. And suddenly, it's perfectly clear. Alice is in Maths, Bob is in English. We've connected the dots.
You know, that join we just did, it wasn't really magic. It was the result of a very structured way of thinking. And this is what we call the programmer's mindset. It's not about just randomly typing code. It's a process. You start by clearly defining your problem. I need to connect students to class names. Then you figure out your inputs, our two tables, and what you want your output to be, a single combined table. You map out the steps, the algorithm, and only then do you translate that plan into R code. It's this disciplined process for solving pretty much any problem with data.
So we've just taken a really quick tour of this new language. We've gone from the big idea of asking questions all the way to combining complex information. You've basically just learned the alphabet and some of the basic grammar. Now it's time to start writing. And that really is the fundamental journey, every time. You start with curiosity, with a question. You use the language of R, with its nouns, the variables, to store your facts, and its verbs, the functions, to take action. You organize everything into data frames, and you connect them to build the full picture. That's the path you take to find your answer.
So we're going to leave you with this thought. You've now seen the basic tools that data scientists use to uncover hidden truths. But remember, the real power isn't in the code itself. It's in the curiosity that drives the questions you decide to ask in the first place. Every single data set out there has a story to tell. So, what story will you uncover?